www.liveexamhelper.com/www.liveexamhelper.com/. Problem 1. Recall that an M-simplest signal set is a set of M signals A equals a 1E1J less than M in an EM1 dimensional real space Ri, such that, for some EA0, initially we will assume that AF is a power of 2, M equals R, for some integer M. A. Compute the nominal spectral efficiency PA and the nominal coding gain 7JA of an AL-simplex signal set A on an AWGN channel as a function of M equals 2M. The AF simplex signal set has AF equals 2M points, so the number of bits per symbol is log 2 AF equals IN. The number of dimensions is N equals AF, 1. The nominal spectral efficiency is therefore this equals 2 for M equals 2 and decreases monotonically with M, so we are in the power-limited regime. Indeed, as the nominal coding gain in the power-limited regime is defined as the squared distance between any two distinct signals is liveexamhelper.com. So, the energy per signal is EA, so the energy per bit is the nominal coding gain is therefore this equals 1 when Ni equals 2, and increases monotonically, albeit slowly, with Ni. As M co itv. B. What is the limit of the effective coding gain NFF, A, of an Ni simplex signal set A as NiOO, at a target error rate of as shown in 6.450 and reiterated this term, orthogonal or simplex signal sets approach the ultimate Shannon limit on EB/no as BL/OO, i.e., they can achieve arbitrarily low PRE for any EB/no 1N2 minus 1.59 dB. For the baseline 2PAM signal set, when therefore the limit of SE, give a method of implementing an M equals 2'1 simplex signal set A in which each signal AJ is a sequence of points from a 2PAM signal set, plus or minus A. We saw in the problem sets that the Euclidean image of a 2'1 M, 2" I, binary linear code C could form a 2M simplex signal. liveexamhelper.com. Set, in two different cases, C is obtained by shortening a 2'M plus 1, 2-1 by orthogonal RM, 1M code. C is a maximum length shift register code generated by a length M shift register. In either case, each signal AJ is a sequence of 2'1 points from a 2PAM signal set. In 6.450, you also saw a construction of an orthogonal signal set from a Hadamard matrix. Now consider a concatenated coding scheme in which the outer code is an NKD, linear code C over a finite field FQ with Q equals 2', which has ND codewords of minimum non-zero weight. Outer Q array code symbols are mapped into a Q code symbols are mapped into a Q simplex signal set via a 1-to-1 map S, FQ, A. If x equals 11 x2 xn is an n-tuple in FQ degree, then S x equals S x1 S x2, S x will be called the Euclidean image of x. Let A equals S C equals S x x e c denote the signal set consisting of the Euclidean images of all codewords x e c. D. Compute the nominal spectral efficiency P of the concatenated signal set on an AWGN channel. Is this signal set appropriate for the power-limited or the bandwidth-limited regime? The size of A is I equals ICI equals QK, and the dimension of A is N, Q, 1. Therefore, liveexamhelper.com. And we are in the power-limited regime. E. Compute DM2 in A1, ich, 0.41, and 7C, Give a good estimate of an appropriately normalized error probability for a The squared distance between the Euclidean images of two distinct code words x, y, e, c that differ by Hamming distance dh, x, y is. Since the coordinate y's distance is dilly, a, in each coordinate where the two words differ, and I, otherwise. Therefore, and moreover every point in a has kmin, a, equals nd nearest neighbors. Since EB, al, equals n/k, eo, a, the nominal coding gain is. Notice that this reduces to liveexamhelper.com. The union bound estimate, UBE, gives a good estimate of the error probability PRE. In the power-limited regime, we normalize to the error probability per bit, PBE, and express it as a function of EB/no. The UBE of PBE is where we use the fact that log 1a I equals k log g bits. Now consider the case in which C is an n equals g plus 1 k equals 2 d equals q linear code over fq. F. Show that a code C with these parameters exists whenever q is a prime power, q equals pm. Show that all non-zero codewords in C have the same Hamming weight. A finite field fq exists whenever q equals pm. In an exercise which we did as a homework problem, we showed that a doubly extended n equals q plus 1 k d equals n k plus 1 rs code exists over any field fq for 1k less than 72. Thus there exists a q plus 120 code over fq. Its generators are examples: the 322 SPC code over F2, the 423 tetracode over 1F3, a 524 code over F4. A q plus 1, 2 q code is MDS, and therefore liveexamhelper.com. Thus all Q2-1 non-zero codewords have Hamming weight d equals q, g, show that the Euclidean image A equals S, C, of C is a Q2 simplex signal set. The number of points in A is I al I equals IC, I equals Q2. Each point in A is a sequence of Q plus 1 points in A, so the dimension of A is. The energy of each point in A is EA equals Q plus 1 EA. Since the inner product between symbols is EA where they agree and EA slash Q1 where they disagree, and any two distinct points x, y, EA agree in one component and disagree in Q components, we have. Therefore is a Q2 simplex signal set. Thus we can see how we might recursively generate simplex signal sets with 2, 4, 16, 256, 216 points, starting from a 2-PAM signal set and using doubly extended Q plus 1 2 Q RS codes over FQ. liveexamhelper.com. Problem 2. A. Let P, T, be a complex 2-pound signal with Fourier transform P, F. If the set of time shifts, P, T, KT, KEZ, is orthonormal for some t greater than 0, then P, 0, number 0. False. The orthonormality condition is. This can be satisfied by, example IP, F, 12 equals T for 1 slash T less than F less than 2 slash T and P, F, equals 0 elsewhere, including P, 0 equals 0. B. Let S, C, be the Euclidean space image of a binary linear block code C under a 2-PAM map S, 0, 1, plus or minus A. Then the mean M of the signal set S, C, is 0, unless there is some coordinate in which all codewords of C have the value 0. True. This proposition holds if and only if half the codewords in any binary linear code C have a 0 in any coordinate position, and half have a 1, unless all are 0. liveexamhelper.com